Hello everyone and welcome to the next instalment in this Puzzles and Games series. The puzzles this week all involve going last. How can we make sure that we're the player that goes last, takes the last action, and what strategies do we have to employ to make sure we get to that point? Hope you enjoy. So here's the first game. This is one many of you may be familiar with. It's called NIM or 21, all sorts of different variations. The game is very simple. You and an opponent take it in turns to count up to 21. You can say one number at a time, 2 or 3, and the winner will be the person who says the number 21. So, for example, if I record the numbers that me and my opponent say, perhaps I might start with 1, 2. My opponent can then go 3, 3, 4, or 3, 4, 5. Let's say they go 3, 4, 5. And me again, I'm going to go 6, 7. My opponent might go 8, 9, 10. I'm going to go 11. My opponent goes 12. To speed this up a little bit, I'll go 13, 14. My opponent goes 15, 16. I'm going to go 17. My opponent goes 18, 19, 20. I'm trying to think they can get there, but of course they're only allowed to say a maximum of 3 numbers at once. And so I win by saying 21. And that's the game. You might have played this with your friends at school, who knows. What I'm interested in here is, what is our strategy for winning this game? How can we make sure that we're the one who gets to say 21? So there's a few different things to consider, and there's lots of different ways you can think about games like this. But I guess what we're going to try and examine here is what we might call states of the game. So games like this involve decisions. Both you and your opponent get to make that decision. You can't control what they say. What you do try and have control over is, I guess, what number you leave them. So you'll notice in that last game, I left my opponent, or I ended on the number 17. At this point, I knew I'd won, because my opponent can either say one number, 18, 2 to 19, or 3 to 20. But in all cases, I'm going to be able to get to 21. So a game state where the current total is 17, or I've just said 17, means I win. So if I can get to 17, I win. But then of course we need to track that thinking back. How can I get to 17? How can I make sure I'm the one that says 17? Well, what I'm going to do here is I'm going to go back a block of 4. I'm going to think about the number 13, because if I say 13, doesn't matter what my opponent says, 14, 15 or 16, I can make sure that I can add the right number to get to 17, and then from there to 21. And you can track this thinking backwards, and you can see that if I say 9, I'm going to be able to make sure I say 13, and so on, and even further back to 5, and even to the number 1. So it feels then that I can win this game by going first, and by saying the number 1. Now that seems quite remarkable, because as I said, there are choices to make and your opponent can choose whatever they want, but it doesn't matter what they choose. Once I've said 1, so long as they stick to the rules, they go 2, 3 or 4, I can definitely say 5. Doesn't matter what they say, I can definitely say 9, and so on. So we're looking at the game as a series of chunks of 4. Now I start by saying 1. And it doesn't matter if they just take a little piece of this and they say 2, I'll definitely be able to make it up to say 3, 4, 5, because of course this takes us to a total of 5. And then it doesn't matter if they take a whole big piece of this, they say 6, 7, 8, I'll still be able to add that 1 in to get to 9. And this is why we're looking at blocks of 4, because being allowed to say 1, 2 or 3 numbers, I can always say that extra number to make it up to 4. They go 1, 2, 3, I go 4. 1, 2, 3, 4. 1, 2, 3, 4. So we're looking at multiples of 4 because each player can only say up to 3 consecutive numbers. Anything they knock out of the block of 4, I can just knock out the rest to make sure that I say the next key number. So if we're here at 9, my opponent says 10, 11. I can definitely say 12 and 13, get back to that key winning number there, 13. And that's how the game is going to progress. Each block of 4 taking us closer to the resolution where I eventually get to say 21 and win. So the method here is to look at what does the winning state look like and step backwards through the problem to give us a strategy and tell us how to begin. And that technique is useful in all sorts of other puzzles, but also in problems in the real world, thinking about what success looks like and then stepping backward about how to get there. This brings us on to our next puzzle. Again, this is a go last puzzle, and in this game the idea is to simply remove the final cone. The rules are a little different, and I guess the mechanics of the game, how it works, do inform our strategy a little bit. So things are a little bit different this time. You can remove either one cone, we'll just put crosses through them this time, or you can remove 2 cones if they are next to each other. So just to be clear, I can remove these 2 because they're next to each other. I could not remove these 2 because there's actually a gap between them. I'd already removed that one previously. So that's the rules of this game. And again, you might want to have a little pause here and play this with a friend. But how can we strategize so that we remove the last cone? Again, this is about taking the last action for a win. So we know what, perhaps we can think about what the final state might look like. We win if there's only just 1 cone left, obviously, or we would win if there were 2 cones right next to each other left. So we might want to track that back and think, okay, well, what do I need to leave my opponent to get me to this position? But it's a little bit tricky this time, because you might think, okay, I'll leave my opponent in this scenario where there's 2 together and 1 separate. But of course my opponent could be quite shrewd here, just removing one of these and leaving 2 single cones, one that I'll have to take and one that they'll have to take. So not quite as easy to think our way through this. We need to manipulate this into a situation whereby we're always going to be able to have 1 more move after our opponent has moved. And it's compounded by the fact that we have this, sometimes you can take 2, sometimes you can take 1 rule. So how do we progress here? Well, this is a nice example of this kind of puzzle because it uses a little bit of symmetry. So symmetry is an idea we all learn about, we see out in the real world, but the idea here is if I can create 2 symmetrical halves to this game, whatever my opponent does, I'm going to be able to do on the other half. And so I won't run out of moves until my opponent has run out of moves, in which case I will win because I act last. So the trick with this game is to create that scenario. So we start with an odd number of cones. In this case, I think we have 13. And I'm going to take out the middle cone here. This one here. Oops, this one here. Now I've created 2 separate groups of 6 cones. And whatever my opponent does on one half, I'm going to do on the other. Here we go, they take a single cone there. I'm not just going to take a single cone on the other side, I'm going to take the reflection of their move, leaving 2 exactly the same states on either side. If they now come over my side and they take these 2 perhaps, I'm going to take these 2. And so long as I'm still visualizing the game in terms of this line of symmetry that I created with my first move, I will mirror whatever action they take. They might come over here, I'll go over there, they come here, I'll take this one, and then finally we've got 2 single cones left where my opponent takes one and I take the last one. So here that idea of symmetry allows me to manipulate the game so that whatever move they take, I always have an answering move. So again, a slightly different way of thinking about it this time, but we're still trying to control as much as we can of the game to force that last situation that we're interested in. So there we go. Those are the 2 examples I have for how to win these sort of go last games, if you like. I have one more example I want you to have a little think about. Maybe drop some comments for me below if you think you know a solution to this one. In this game, you have a round table. It's perfectly round, so it's a circle as you've got here, and you and your opponent are going to take it in turns to place coins on the table. And you can place the coin anywhere you like, but it's not allowed to overlap another coin. That's not allowed. We can drop it over here, or we can pop one in the middle. Anywhere is fine, but no overlapping, and the coins are not allowed to sit off the edge of the table. Now, this is the same thing. The person who places the last legal coin wins. It has elements of the other two solutions in it, but how can we make sure that we get to place the last coin here? It's a tricky one. It seems like there's not enough information, you know, how big is the table, how big are the coins? Those things are actually not relevant to the solution. So have a think, how can we manipulate the states of this game to ensure that we take the last action? Let me know below what strategy you have for this game.